Welcome to True Projects. In this video, we are going to explain about a project titled Diabetes Prediction using Ensembling of Machine Learning Classifiers. The project revolves around diabetes, a chronic condition characterized by high blood sugar levels over an extended period. Diabetes occurs when the pancreas fails to produce enough insulin or the body cannot effectively use the insulin produced. This can lead to the various health complications. Recent studies have indicated a significant increase in the diabetes case among the adults in both developing and undeveloped nations. In the response to this, the project aimed to develop a strong framework for diabetes prediction using the machine learning algorithms and ensembling classifiers. The main goal of this project is to introduce a strong and effective framework for predicting the diabetes using the machine learning algorithms and ensembling classifiers. The project aimed to enhance the diabetes prediction by tackling the challenges posed by the limited label data and existence of the outliers or the missing values in the diabetes dataset. To evaluate this proposed framework, performance is tested on the diabetes dataset. The basic requirements that are needed to build this project are software requirement, Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. The project begins by importing the essential Python libraries such as NumPy, Pandas, sklearn, Keras, Flask, and other relevant libraries. These libraries are essential for the tasks like data manipulation, data pre-processing, machine learning model building, and the web development using the Flask. And the second one is exploring the dataset. The dataset typically stored in a CSV file containing the relevant features such as the number of pregnancies, blood pressure, insulin level, age, and more. And this step, exploratory data analysis is performed to understand the dataset structure, distribution of data, and the potential relationship between the variables. And the third one is data processing. Data processing involves cleaning and preparing the dataset for the model training. This step includes handling the missing value, scaling or normalizing the features, and encoding the categorical variables if necessary. Data processing ensures that the dataset is in a suitable format for the machine learning model. And the fourth step is splitting the dataset to the train and the test. To evaluate the model's performance accurately, the dataset is split into the two subsets, the training set and the testing set. The training set is used to train the machine learning model, while the testing set remains unseen and is used to assess how well the model generalizes to new and the unseen data. And the fifth step is building the model. Multiple machine learning models are built and trained using the training data set. The first one is k-nearest neighbor. It's a simple and initiative algorithm used for both the classification and the regression task. It assigns a class label or predict a value for an instance based on the majority class or the average value of its k-nearest neighbor in the feature space. KNN is a non-parametric, meaning it does not learn a model during the training but rather stores the training instance to make predictions at runtime. It commonly used in recommendation systems and of test recognitions. And the second one is random forest. Random forest is an ensemble learning method that combines the multiple decision tree to improve the prediction accuracy and reduce overfitting. It creates several decision trees during the training and aggregate their prediction through majority voting and averaging. Random forest is robust, scalable, and less prone to overfitting compared to the individual decision tree. It is widely used in applications such as of remote sensing and the financial forecasting and of many more. The third one is decision tree. Decision tree is a tree-like model where each node represents a feature, each branch represents a decision based on that feature. and each leaf node represents a class label or the regression value. The algorithm recursively splits the data based on the most informative features, resulting in a tree-like structure that can be used for the classification or the regression task. And the fourth one is AdaBoost. AdaBoost is an ensemble learning technique that combines the multiple weak classifiers to create a strong classifier. It iteratively trains the weak learners on the different subsets of the data and assigns the higher weight to the misclassified instance in each iteration. This process focuses on the difficulty to classify the instance, resulting in a more accurate and robust model. AdaBoost is used in various algorithms to dictate purpose. And the fifth step is naive Bayes. Is a probabilistic algorithm based on the naive Bayes theorem, which calculates the probability of the particular instance belonging to the certain class. It assumes that the features are conditionally independent given the class label, making it computationally efficient and well suited for the high dimensional data set. And the sixth one is XGBoost. Stands for Extreme Gradient Boosting, is a algorithm known for its high performance and efficiency. It is an optimized implementation of the gradient boosting framework and uses the tree-based learning algorithms, where it particularly popular in machine learning competitions that will have ability to handle the large data set, deal with missing values, and achieve the high prediction accuracy. And the seventh one is MLP. MLP stands for Multi-Layer Perceptron. Is a type of artificial neural network with multiple layers of interconnected nodes. It is a versatile model capable of approximating the complex non-linear relationship between the input features and the output label. MLP is widely used in various tasks, including the image recognition, natural language processing too. And the sixth step is training the model. The machine learning models are trained on the training data set. During the training, the model learns from the input data and adjusts the internal parameter to make the accurate prediction. The seventh one is user gives the input. Web application is created using the Flask framework, which allow the user to view the input of the data for prediction. The Flask interface provides a form where the users can enter the relevant input data such as of number of pregnancies, blood pressure, insulin level, age, and many more. And the eighth step is the given input is pre-processed for prediction. The user input data is pre-processed to match the format used during the model training. This involves scaling, normalization, and necessary feature transformation. And the ninth step is trained model is used for prediction. With the pre-processed user input, the trained machine learning model are employed to predict the final outcome. Each model processes the input using its learned parameter and produce a prediction based on the input feature. And the last one is final outcome is displayed. The prediction outcome is displayed to the user through the Flask web application. The user can see this classification result, providing the valuable insight for the decision making or the future action. And the execution of the project, first we need to open the code folder. This is the code folder containing of the different files within it. The template folder, the static folder containing of the images within it, and the template folder containing of the HTML documents like of index and result, and the app is an py file which contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the diabetes prediction using Ensemble learning classifiers is an IPYNB file which contains the combination of the code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And to execute the project, first we need to build a Flask framework, and the overall code in the form of graphs and output all are present in the IPYNB file. For the execution, first we need to copy this code folder address and then open the Anaconda prompt. Here, first we need to change the directory position as F2, and here we need to write and command cd space paste this address By this, the directory is changes to the code folder's path and then click on enter button. After this, we need to write and command python space app.py. By this command, it will execute the Python script and recover and the runtime check for the syntax errors or the logical issues, and then click on enter button. By running this app.py file, the Flash framework will host the application locally at the default address as of this. We need to copy this local link and paste it on any of the web browser. I preferably use the Chrome and pasted this address and then click on enter button. It redirected to this home page containing of the different features within it, and we need to enter the detail. As of number of pregnancies is of 8, and the glucose level is 183, and the blood pressure is of 64, and skin thickness is of 0, and the insulin level is of 0, and the body mass index is of 23.3, and the diabetes pedigree function is of 0.672, and the age is of 32, and then click on the predict button to predict the diabetes. After clicking the button, we move to the result page. As a result, oops, you have diabetes. In this way, we can predict the diabetes of a person. And click on the back button and refresh button. Here we can re-enter the details as of 2, and the glucose is of 124, and the blood pressure is of 72, and skin thickness of 19, and the insulin level of 145, and the body mass index of 25.8, and the diabetes pedigree function of 0.527, and the age of 21, and then click on predict button. Here we get a screen of wow, you don't have diabetes, and this way we can predict whether the person having the diabetes or not by using various machine learning and ensemble learning methods. In conclusion, the project proposes a robust framework for diabetes prediction using the machine learning and the ensemble classifier. The proposed framework outperforms the other methods discussed in the article and provides the better results on the same dataset, which lead to the better performance in the diabetes prediction. The quality of the dataset was improved by the pre-processing scheme, where the outlier rejection and the filling the missing values was a core concern. The performance of the proposed framework was evaluated using the diabetes dataset, and the results showed that the proposed ensembling classifier is the best performer classifier. That project concludes that the proposed framework can be used for the accurate and robust diabetes prediction, which can help in early diagnosis and treatment of diabetes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.